Hey guys, this video is to explain section 9C. I'm going to be working on pages 8 to 11. So in this section we have theoretical probability to work on, and in this case you're going to see a bunch of rules. So rule number 1, if we want the probability of some event A, remember that's the notation, P parentheses A, we're just going to have to do a counting process. And this is a counting process that you would have been instructed how to do in the previous section where you've listed out sample spaces. So all I'll have to do to get the theoretical probability that event A happens is count the number of outcomes that are in event A over the total number of outcomes in the universe or the sample space. And once I have that ratio, I have a probability. One thing I need to write here is that this assumes each outcome in the sample space is equally likely. So it's only really for the simple experiments with equally likely outcomes. All right, rule number 2. Two events are considered complementary if exactly one of the events must occur. If A is an event, then A prime is its complement. A prime is translated as not A. You've seen that notation in the sets chapter for the complement of a set. So if either A happens or it doesn't happen, like it's either going to rain tomorrow or not rain tomorrow, those two probabilities should add up to 1. So if we say there's a 20% chance of rain, then there's an 80% chance that it doesn't rain. Often this complement rule is written as a subtraction rule, where I get the probability that A doesn't happen from 1 minus the probability that A does happen. Okay, so if I have an experiment of rolling a fair 6-sided die, and A is the event that it lands on a number greater than 4, all I would have to do to find this P of A is to think first about what's in the sample space, that it's just a list of the numbers 1 to 6, and then I have to think about what is in event A, only the numbers 5 and 6. So if I follow that rule above, P of A has 2 out of the 6 outcomes in the sample space. So feel free to leave an answer 2 over 6, or 1 over 3, or a 3 sig fig decimal. Okay, the complement of A, if I wrote it in word form, would be A primed, and the event that the die lands on a number greater than 4, its complement would be die lands on number less than or equal to 4. So that means A primed would have 1, 2, 3, and 4 in it. So using the probability rule number 1, I can say, oh, well, it has 4 out of the 6 outcomes in it, which is 2/3 or 0.667. Or I can follow that complement rule and get P of A prime, knowing I already had P of A worked out, to just be 1 minus 0.333, to also get 0.667 that way as well. All right, so some examples to model those two rules. If I have a carton of a dozen eggs that has 8 brown ones and the rest are white, how many white ones are there? Okay, so some simple math right here in part A. 12 take away 8 would be 4. Part B, what's the chance that I randomly pick a brown egg? Well, following rule number 1 above, this is really simple, guys. There's 8 brown ones out of 12 eggs in the carton, and the probability I get a white one, there's 4 white ones out of 12 eggs in the carton. Okay, turning the page. Okay, suppose I have, let's see, 3 people. What's that name? Auntie, Kai, and Nita. They're going to sit in a row, and I have to list the 6 different orders in which they can sit. Okay, so if my sample space is about reordering 3 people with the initials A, K, N, I'm going to recommend that we draw this out vertically. So let's keep A first, and switch the order of NK. Let's put K first, then AN, K first, then NA, or N first, followed by AK, or N first, followed by KA. That would be the 6 different orders. All right, so now the probability in part B. What's the chance that we have ante in the middle? So ante in the middle, I'm going to shorten this, otherwise my video is going to be too long. All right, so number 1, ante's in the middle. All I do is go count. That happened 2 out of 6 times. This is just rule number 1. Let's see, number 2, ante's at the left end. Well, that happened 2 out of 6 times. Roman numeral 3, ante's not on the right side. Okay, well, she's not on the right side 4 out of 6 times. And Chi and Nada are together. So K and N would be together here, 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 and here. They're together 4 out of 6 times. All right, how about 8 possible 3-child families by gender? Okay, so by gender, 8 possible. I'm going to again suggest that it's ideal to think about this vertically. I'm going to start you off here with boy, boy, boy. And then we're going to finish at the end with girl, girl, girl. Do you remember those true-false logic tables we filled out? There's 8 arrangements here. So I can do 4 B's, 4 G's. And then I can do doubles. And then I do every other. All right, so that would be the sample space of all possibilities in a 3-child family. So part B, what's the chance that my family's got all boys in it? Well, 1 in 8. B2, all girls in it, 1 in 8. Notice these are all equally likely outcomes, so I'm following that simple rule number 1. Boy followed by girl, girl, only 1 in 8. 2 girls and a boy. So 2 girls and a boy, let's count. That one, 2 girls and a boy. That one, and that one. That would be 3 out of 8. Roman numeral 5, a girl's the oldest. So if the left is the first child, notice that the girl is oldest in 4 out of the 8 families. And part 6, at least 1 boy. Well, there's at least 1 boy except for the girl, girl, girl outcome, so that's 7 out of 8 chance for that. Okay, flip the page. Okay, so those previous problems just relied on me being able to list out sample spaces that had equally likely outcomes. What if we had to work with grids? Still following rule number 1. Here's a pair of dice rolled with a grid shown. 36 outcomes represented by those 36 dots. Use the grid to determine the probability that we roll 2 3s. So 2 3s, you guys, that's only this dot. That's a 1 in 36 chance. Part B, rolling a 5 and a 6. So we have a 5 and a 6. So a 5 and a 6, this die roll has a 5 and a 6, and this die roll has a 5 and a 6. So 2 out of 36. Part C, a 5 or a 6. And an or in probability. Super important to pay attention to that. And an or. So now if we say 5 or a 6, let's see what we have to go count. Right? 5 or a 6. All of these rolls that I'm circling have a 5 or a 6 as part of the roll. It's okay if they have 2 5s, it's okay if they have 2 6s. Every one of those rolls have a 5 or a 6. So if we count that, That would be 20 out of 36 rolls. Notice I'm not spending my precious time simplifying fractions or changing them to decimals. Part D, at least 1 6. At least 1 6. So I have at least 1 6 in all of these dots, and all of these dots. So that looks like a total of 11 out of 36. Part E, exactly 1 6. Right, probability is very exact. Pay attention to the prompts. Exactly 1 6 means I have to exclude the double 6 roll. So that looks like 10 out of 36. Part F, no 6s. Well, no 6s happens inside here. No 6s. These rolls right here have no 6s in them. That's 25 rolls. Notice that part D and part F, at least 1 6 and no 6s, they are complements of each other. They add up to 1, part D and part F. Okay. Suppose I have a coin and a pentagonal spinner that's got the numbers 1 to 5. Tossed and spun. Draw a grid for this chance process. All right, a pentagonal spinner and a coin. So the coin's only H or T. The pentagonal spinner is 1, 2, 3, 4, 5. So I would have a sample space that has 10 equally likely outcomes in it. Remember, these rules that I'm working on, these simple ones, are only for chance processes that have equally likely outcomes. Okay, so part B, how many outcomes? 10. Part C, Roman numeral 1, what's the chance I rolled a tail and a 3? That's only 1 in the 10 outcomes. A head and an even number, that'd be these two, so 2 out of 10. Roman numeral 3, an odd number. All right, so that means we don't care what comes up on the coin, we just care that the spinner landed on something odd. So that's a 6 out of 10. And Roman numeral 4, a head or a 5. Remember that and versus or is a big deal. A head or a 5. A head or a 5. So those 6 pink dots I just put there count as an outcome that has a head or a 5 in it. So 6 out of 10. Okay, turn on the page. Finally, table of outcomes. That's basically using a two-dimensional grid where instead of dots, we've got a table of outcomes that shows the results of what could happen in the chance process described. So if we roll 2 dice and we add scores together here in problem 1A, and it's asking me for a grid with outcomes, you can see here I have to add my rolls together. If I add 2 with the other numbers, I'm going to get 3, 4, 5, 6, 7, 8. 3 with these numbers is 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. So now part B is easy if I have this table of outcomes. What's the chance that a sum of 11 shows up? So B, Roman numeral 1, 2 out of 36. Roman numeral 2, 8 or 9 show up. Just go in there and count. Go count your 8s or 9s. Let's go highlight them. I found 9 out of 36 outcomes. Roman numeral 3. Less than 6 shows up. That would be all of these. So 4, 7, 8, 9, 10 out of 36 chance for that. Okay. Both of these spinners are going to get spun and the scores are multiplied together. Draw a table of outcomes and find these probabilities. Video's getting already kind of long. My notes are filled out online. Hope this helped. That was section 9C, pages 8 to 11.